All right, so we're actually going to divide chapter 7 into 2 parts. We're going to do 1 to 4, take a test, and then it's long. It goes to 8. So then 5 to 8 will be the next test, which is the third test of the third quarter. 1 and 2 and 3 are systems of equations. So a lot of this you should remember from Algebra 1 and Algebra 2. And then there's obviously application that's going to push it a little bit further. 7 also brings in matrices, if you remember all that fun stuff that comes at the end. So start with just like systems of equation. What is a systems of equation? A system of linear equation is 2 linear equations, linear meaning 2 lines, where you have 2 equations with 2 variables, which means you're going to get an x and a y. Okay, a linear equation would not have any kind of squareds or square roots or anything like that. They're just going to have straight up x and y. And a solution to the system of linear equations is 2 variables in an ordered pair that satisfies both equations in the system. So if I tell you that 2, 3 is a solution to a system, it has to work in both equations. So if you're checking answers, you're going to make sure that you're plugging into both. So that first example is just that. Determine if the ordered pair -1, 3 is a solution to the system. So the x is your -1, the y is your 3, and then you're going to take them and you have to plug them into both. So into this one would be 2 times -1 minus 3 equals -5. I get -2 minus 3. And -5 equals -5. So I know it works for the first one, but again, you have to test both. So now I'm going to plug it into the second one, and I would get x, which is -1, plus 3 equals 2. -1 plus 3 is 2. 2 equals 2. So yes, it is a solution. If it doesn't work in either of them, it's a no. So if you plug it into the first one, it doesn't work, you can immediately say no, you don't even have to plug it into the next one. It has to work for both in order for it to be a solution. With me so far? So one way to find a solution is from a graph, which will eventually graph these. The solution of the system of linear equations can sometimes be found by graphing both the equations in the same rectangular coordinate system. For a system with one solution, the coordinate points of the intersection give the system's solution. So if the graphs intersect at one spot, then that single solution, which on this one is 4, -1, would be your solution. If these turn into nonlinear like a parabola and a line, you can have 2 solutions, okay? You can also have no solutions, so if they do not intersect at all, like you've got a line that goes like this and a parabola that goes like this, okay, then there's no solution. So parallel lines would be an example of this, okay? If they end up with the same line, so sometimes they are disguised, like if it said 2y equals 4x plus 6, that's the same thing as y equals 2x plus 3. Those graphs would be the same thing. If they end up being the same line, then your answer is all real numbers. So there's always 2 special cases, no matter what kind of system it is. Your no solution, which means they'd never intersect. When we get to equations, you'll see how that happens. And then all real numbers, which means that the lines would overlap completely, like one line right on top of the other. They end up being the same line. All right, the first method we're going to go step by step through is substitution. So if you remember from, again, Algebra 1, Algebra 2, there's substitution, there's graphing, there's elimination. We will eventually get to all 3. And when it says to solve at the end, it will be your choice how you do it. For the process of building there, if it says to solve using substitution, you need to solve using substitution. You could check other ways, but you need to start there. So what we're going to do is we're going to take one of the equations, and it doesn't matter which one, and we're going to solve for one of the variables, and again, doesn't matter which one you start with. You're going to plug that expression into the second equation, the one you didn't solve for, in place of the same variable you solved for. You're going to solve for that because you're only going to have one variable left. And then you're going to take that and plug it back into either equation and solve for the remaining variable. Again, special cases come if the variables cancel out. And what's left is a true statement. Like 2 equals 2 or 0 equals 0, then this is an all real numbers scenario. If what's left is a false statement, like 0 equals 2 or negative 1 equals 4, then the answer is no real solution. So all real numbers, when you're like, if you're doing this like a short answer, you can put the little r that looks like that. That implies all real numbers. No solution, you could put a 0 with a strike through it. These are the symbols you can use, okay? Your web assignment will tell you what to use if those are your answers. So again, that's only if both variables cancel out. So if you get rid of the x and you get rid of the y and what's left is false, it's no real solution. And if it's true, then it's all real numbers. So again, make sure you pay attention to directions. At this point, it's going to tell you what way to use. Solve by the substitution method. So I'm going to look at my two equations that are there, and I'm going to see which one is easier to solve for a single variable. What's easy to solve for? The y in the top, right? It's already by itself. As far as it's not being multiplied by anything, all I'd have to do is subtract the 5x. So I get y equals 9 minus 5x. It's not the only way you could do this, but I would have probably picked that one too. Then I'm going to take what y equals in that first equation, and I'm going to plug it into the y in the second equation. And I get negative x plus 3 times 9 minus 5, x equals 11. And then I distribute the 3. Combine my like terms. Subtract the 27. Divide by negative 16. And I get the first answer, which is that x equals 1. Then I have to take and plug that back in. I can plug it back into either of my original ones, or I can plug it back into the one I solved, which is already solved for the y. So a lot of times that's the easiest. So I would say y equals 9 minus 5 times 1. Y equals 9 times 5. Or not times 5. Minus 5. Y equals 4. And now I've got both the x and the y. Your answer will be written as a coordinate point. X first, y second. If we had extra time on this, we could quickly take those, plug them back in and check, so you would know that your answers are right. If this is multiple choice, which it won't be in here, but let's say that this is a standardized test, these are easy to plug in, right? You could go work your way backwards. If I had multiple choice, plug them in instead of taking the process of solving. Sometimes that's faster. All right, this one obviously has decimals, so you've got options. You can continue to work with the decimals, or you can get rid of the decimals so that they are all whole numbers. So if I wanted to get rid of a 1/10 in the top, how do I do that? Multiply everything by 10. So the entire equation gets multiplied by 10 all the way across the equal sign, which is what people mess up. Then take the second one. Still only one decimal place. So if there was 1 with 1 and 1 with 2, I would multiply 1 by 10 and 1 by 100. Okay? Whatever you do to the equation has to do the whole thing. So this would also be by 10, and then I get 3x minus 2 equals 1. So I move my decimal place one place to the right. Now it's not as simple to substitute. Eventually, when we get to elimination, this is probably easier to do elimination. I would just multiply by the bottom by 4, get rid of the y's. But this is specifically saying use substitution. So I got to solve one of those equations for one of the variables. Let's just say we pick second and we pick 3. I mean, pick x. It doesn't matter. You have to move and divide either way, and you're always going to get a fraction. So if I did 3x equals 1 plus 2y, and then divide by 3, and I get x equals 1 plus 2y over 3. Now I'm going to take that and plug it into the first x. So 15 times 1 plus 2y over 3 plus 8y equals 23. 3 goes into 15 5 times, and then I distribute that. Subtract the 5, combine these two, divide, and I get y equals 1. So again, that's the first part of my answer, y. Then I take and plug that back in. You can plug it back in anywhere, but if I've already solved this one for x, then I can plug it in there. 1 plus 2 times 1 over 3 which is also 1. And again, you can take the time to check those. Use a graphing utility to verify. So to use a graphing utility to verify, these have to be solved for y. All of your calculators are y equals calculators for the most part, which means I would have to take each of these equations and solve them for y. They can be as messy as you want them to be, okay, because your calculator can handle fractions with decimals, but you do have to solve it for y. So if I'm going to take 1.5x plus 0.8y equals 2.3, I can either use that one or I can use this one. It doesn't matter. 15x plus 8y equals 23. And then I need to solve it for x. So I'm going to use the second one. I'm sorry, solve it for y. Subtract the 15x. And then divide by 8. So when I type this in the calculator, I've got to group it. 23 minus 15x, grouped it, divided it by 8. And then you're going to type that in the calculator. And then I'm going to do the next one. So I'm going to pull this one over. 3x minus 2y equals 1. Negative 2y equals 1 minus 3x. Divide by negative 2. And y equals, again, I'm going to group it, 1 minus 3x divided by negative 2. And then I hit graph. Okay, so I typed in my equations, 23 minus 15x, made sure to group that, divided by 8, and then 1 minus 3x divided by that negative 2. And then I'm going to hit graph, and then you're going to see them cross. So sometimes it's nice and obvious where they cross. In this case, these are both whole numbers. It's kind of easy to see it. Sometimes it's not the case. So if I wanted to find the intersection there, I can go to second, calc, and the 5th thing in that line says intersect. So if I just go to that, it will let you trace right on top of the, actually I could have just hit enter. It says first curve, so that's, it doesn't matter which one's which. Second curve, yep, hit enter. Guess, yes, it's going to bring you directly to that point. So if you remember when we did our maximins, we had to do the same kind of a thing. It's going to ask you a question. You have to prompt it. It doesn't matter. If you had 3 lines on here and you wanted to figure out where the intersection is, then it makes a difference, like which one's first curve, second curve. You would have to pair them. Like if I had a red, a blue, and a green line, and I want to know where the red and the green intersect, I have to make sure I hit that first curve, second curve. Not the order matters, but I would establish those. And then guess, it will bring you to these, okay? But it's always going to ask those same questions. First curve, second curve, and then guess. You're going to hit enter on all of them, and then it will bring you to that intersection. Good so far? Yeah? All right, so that question, pay attention to directions. It said use a graphing utility to verify. On a question like that, if I'm grading your homework, I'm looking for the work for the actual substitution, then you're using the graphing utility to verify. A graphed equation is not an answer, and it will not get you the credit for that question, okay? You have to use substitution and then use the graphing utility to verify. All right, solve by graphing. So for these, you're going to graph them by hand. You're going to graph each line. In this case, we're going to start with lines. And then where the line intersects is your solution. And again, we talked about this before, but if the lines are parallel or never intersect, then there's no solution. And if they overlap or it's the same equation, then your answer is all real numbers. So I also want to be really clear that on homework for these, I should see a graphed function in Notability. So you should be graphing and pulling a coordinate grid. Probably the best thing to do so it's accurate. You're going to graph these lines, and then where they intersect would be the answer. Do not use your calculator to find these first, because you won't have it on that part of your test. All right, so it says solve the system by graphing. First thing I'm going to do is take this equation and solve it for y. I'm going to get it in a slope-intercept equation, slope-intercept form. So subtract the 3x. And divide by negative 2. Y equals positive 3 halves x minus 7 halves, or 3 1/2. Now I'm going to graph that line. So I'm going to go to negative 3 1/2 And I'm going to go up 1, 2, 3 over 2. I can do it again, up 1, 2, 3 over 2. And then I'm going to connect my line. Then I'm going to graph the second one after I solve it for y. So negative 4y equals negative 6x plus 9. Divide by negative 4. And I get y equals 3 halves x minus 9 fourths, which is negative 2 and 1/4. So now I'm going negative 2 and 1/4. And my slope is up 1, 2, 3 over 2. 1, 2, 3 over 2. What do you know about these lines? What happens when they have the same slope? Parallel. So if they're parallel and they have a different y-intercept, what's true? They're never going to intersect, yes? This is a no solution. If the slope and the y-intercept are the same, then it's all real numbers. But if the slope and the y-intercept are different, God bless you, slope's the same, y-intercept's different, no solution. All right, so what do we notice that's different about this? There's a squared. What's that mean? This is a parabola, right? So this, if you looked at the name of your section, it says linear and nonlinear. This is what the nonlinear is, right? So now we can pull in a parabola, you can pull in a cubic, you can pull in a square root. All the other functions you know how to graph can be overlapped with a line or with each other. You could have two parabolas, right? So you could have more than one solution. So the first thing I'm going to do is take the easy one, solve it for y. So negative y equals negative x minus 4. Y would equal x plus 4. Go up to 4, and then up 1 over 1, or down 1, left 1. It doesn't matter which direction you go in. There's that line. Then I'm going to take my parabola. So now we can use, like we could solve this for y. So negative y equals negative x squared minus 2. Y equals x squared plus 2. We can use transformations to help us with this, but you have to have exact points where they cross. So based on transformations, what do I know about this parabola? It's going up 2, and then is it facing up or is it facing down? Up. So we know it's like this, and then we know it's like this, right? I don't know how narrow or wide exactly it is, and this is where your plotting of your points come into play. So use the transformation to give you an roundabout area. So where they cross, I need to find those exact locations. Because of that, I'm going to take and plug in points until I find one that overlaps. So I would start with negative 1 because it looks like it could cross at negative 1, but we don't know exactly how wide this is. I'm going to take that negative 1, I'm going to plug it in to this equation. So y equals, God bless you, negative 1 squared plus 2, or 1 plus 2, which is 3. So negative 1, 1, 2, 3, and jackpot, I hit one of the points, right? So that's 1, negative 1, 3. Yep. No. No. Then I know it's going to reflect over here, so I get that 1, 1 spot. I'm not going to waste the time plugging in the 1, but maybe that 2 is where the next one hits. So I'm going to plug in 2. Y equals 2 squared plus 2, 4 plus 2, which is 6. 2, 1, 2, 3, 4, 5, 6, and that is on my line. So there's my other coordinate point. So again, I don't want to just plug in points blind, because if this was shifted left or right, I could plug in points all day. What you want to do is use what you know about your transformations to give yourself a roundabout area of your parabola, and then estimate where you think it might cross and plug in those points to verify. Does that make sense? You need exact points. You can't just like eyeball your parabola and then graph it. All right. Now it says solve the system using substitution and use a graphing utility to verify your results. Again, this is nonlinear because I've got a cube, right? So I could have more than one answer here. But it says solve it using substitution. So what's one thing you could solve for? X or y in the first one, or y in the second one? I certainly don't want to solve for x in the second one, right? I don't want to deal with, a cube root of y. So probably easiest is to say that x equals y here by moving the y to the other side. So then in place of the x, I'm going to take the y and plug it in. How would I solve that? It's been about a chapter since you did it. Factor. Yeah. Factor out the y. Now you can either factor it further or split and solve. Either way, you get the same answer. This could be y, y plus 1, y minus 1, or I could split it as y equals 0, y squared equals, or sorry, y squared minus 1 equals 0, and y squared would equal 1, y would equal plus and minus the square root of 1, or plus and minus 1. So you get the same answer here, 0, negative 1, positive 1. So there are 3 y's. For each y, I have to find its corresponding x. So I'm going to take and plug y back in to the easy one, right? X equals y. So if y is negative 1, then I get x equals negative 1. If y is 0, then I get x equals 0. And if y is 1, then I get x equals 1. And now I've got 3 coordinate points. And then I'm going to graph it on my graphing utility. So the first one we already solved for y, it's just x. The second one I'd have to get to the other side. It'd be negative y equals negative x to the third, and then y would equal x to the third. So I typed it in, and then I hit graph. There's my line. There's my curve. Those are really tiny, close together, so you can always choose to zoom in if you can't see it well. But if I go second, trace, and I go to intersect again, this could be my first curve, this could be my second curve, guess. There's 1, hit enter again, come down to here, or go back to intersect. Come over here to the red, or to the blue this way. Here, hit enter, it's going to give me the second one. Do it again, 5 intersect. Now I want to get this one, first curve over here, second curve anywhere over there is fine. Guess, and it's going to bring you to the third intersection. You can also zoom in. Well, that's too close. I would actually probably have adjusted my window and done like -2, 2, -2, 2. Graph it. Well, that wasn't smart because it's, there it is. Okay. So if you are doing it to check, obviously this is easy to check. You can also use you can also use the app that's on your iPad. But on a test, you'll see when we get to these where you have to graph them. Okay. Here comes your application. So this one says use the graphing utility to approximate all the points of intersection of the graph of the equations in the system, round to 3 decimal places, and then verify by checking your results in the original system. So I'm actually going to graph this one on our app, but you could do both. So this time we graphed on the graphing calculator app. Again, you can do this on your calculator where we just did. Okay. And the blue one is obviously the line, and the red one is the square root. And then we double tap the home screen, and it gives us the option to find the intersections, and it brings you directly to it. So up in this corner, it's telling you that the x for both is 2.25, and the y for both is 5.5. So that's going to be your intersection. When it says check your results in the original system, it means take them and plug them in here. So check to make sure they would both work. So if this is an instance probably where you're doing like a square root of a decimal, this would probably be on the portion of your test that you would have your graphing calculator. If you didn't have your calculator, they would be a more exact round number, so you could find it when you're graphing easily. Like you shouldn't be approximating a 2.25 when you're graphing by hand. So you will get part of your test in which you've got to graph it using your graphing calculator and then find information based on it. Questions so far? Okay, now you've got a couple kinds of word problems. Interest problems are the first ones. It says you're given the yearly interest earned from a total of $12,000 invested in 2 funds paying the given rate of simple interest. Simple interest just means if you're earning 5%, you take the total amount of money and you multiply it by 5%. You're not worried about compounding it, like if you remember PERT and all that stuff. You're not worried about continuously compounding monthly. It's just simple interest. Total amount times the rate. And then write and solve a systems of equations to find the amount invested in each rate. This means system, I need 2 equations, 2 variables. So the variables this time are your rates. So let's say rate 1 is, or X is the money invested at rate 1 or 3%. And let's say Y is the money invested at rate 2, which is 5%. So because it says the total amount invested is 12,000, that's the first equation I can set up. X plus Y equals 12,000. It's how much money was put in those accounts. Now the second equation is going to come from the interest. So what's the rate of interest for every dollar put into the X account? 3%, right? So I would say 3% times X plus every dollar is earning 5% in that second account. 5% times Y equals, what's the total amount of interest that's earned? 500. Okay? Can you leave an equation in percent form? No. So what is the same thing as 3%? 0.03. And then 0.05 still equals 500. So X plus Y equals 12,000. So now here's my system. And I will tell you right now, this is the most common mistake people make. You have to go, not most common, there's one more. You have to go from percent to interest. Percent to decimal. So now if I want to solve this using a systems of equation, again, God bless you, I can keep it the way it is. If I don't have a calculator, I certainly want to get rid of these decimals. So what do I have to multiply that equation by? 100. And here's what everybody does wrong. I get 100, they move this one, this is 3x. They move this one, but then they forget that that gets 2 extra zeros too. Now I'm using this equation and this equation, which is going to be easier to solve for a variable. That first one, right? So I'm going to take this. I can say X equals 12,000 minus Y, and then take that and plug it in here. Distribute. Subtract this. Combine these. Divide by 2. There's my Y. I'm going to plug it back in. Actually, I'm going to plug it back in here where it's easy. And there's my X. So when you write these, you will indicate the interest. So you're going to invest $5,000 at 3%, and you're going to invest $7,000 at 5%. Most likely, on this quiz, it will be scientific only, and I'll let you use it for most of it. I'm not 100% yet. I haven't finished the quiz, but I'll let you know. If that's the case, then this is super easy to check because I would just multiply the 5,000 times the 3% and the 7,000 by the 5%. By the time your test comes around, I'll probably separate off the graphing questions, and so you'll be able to use a graphing or a scientific. But just keep that in mind that there's a chance you're probably just doing scientific. Or like a problem like that, you could do without a calculator. Second type of word problem is a break-even analysis. So what does it mean to break even? Do you know? What do you think even would be? If we're talking about revenue and cost, what do you think a break-even is? And nobody's in economics? No? It means you're not losing money, right? You got to the point where you are equal. Your cost is equal to your revenue. So if you are doing a business, right, and you have spent money to buy, I don't know, like t-shirts, okay? You're buying t-shirts, but then you're going to sell them. The point in which you are no longer in the hole, because let's say it costs you $500 to buy the t-shirts and you start selling them, the moment your income hits your hits your cost, that's your break-even point, okay? So this says to find the sales necessary to break even, and R equals C, so revenue equals cost, for the total cost C of producing X units and the revenue R obtained by selling X units, round to the nearest whole unit. So this is your cost. So the way this breaks down, because this one's given to you, but let's just say it asks you to come up with your own cost. There's a flat rate here. So let's say you are, again, I don't even know, this would be an expensive t-shirt. But let's say you're producing something that it costs you $250,000 initially to set up. God bless you, okay? It costs you $200,000, that's your initial investment. That's how much you put into it. Then for each unit you are making, it costs you an additional $8,650. That's how cost works. There's that setup cost, and then there's a variable cost. That's per unit. Now, whatever this is, they're selling for $9,950, so it's good revenue, okay? That is just a per. So you only get one usually for revenue because nobody's paying you up front for a bulk fee. So all I want to do is say where does the cost equal the revenue? So where does 8,650x plus 25 or 250,000 equal 9,950x? That's all. Set them equal to each other, solve. So subtract. And then divide. I'm going to cancel through these zeros, and I get 2, 5, 0, 0 divided by 13. So this is once. Okay, this is 12. That's 9. Okay, so what's going to happen here, I thought I had it rounded, but I didn't for a reason. What's going to happen here is that it's going to repeat, right? Can you sell 0.2 of a unit? Can I sell you the sleeve of a shirt? No. So when you get a unit, if it doesn't come out equal, which is why I did this and I forgot, that you cannot say the lower number. Because if I sell 192 units, I'm still in the red. I haven't made enough money yet. So when you are looking at a break even that ends in a decimal, you will always round up. So if it asks you how many units you need to sell, even if it's a 192.1, you will always say the next one up, which is 193. Because if you round down, which is what you would logically do with 192.2, you are still not breaking even. Does that make sense? So that unit is where you start to make your money. Always round the break even up. Obviously, every time you see break even, not all the other questions, but every time you see the break even, you always want to make sure, one, it's a whole unit, and it said that in there, but you also want to make sure you're rounding up, because if you round down, you haven't made enough money to break even. Correction on this one, this actually should have been a 4. Still doesn't change, except this would have been a 3. It still needs to be rounded up. It still needs to be 193 units. Okay, last type of question is back to geometry. So this one is the perimeter of a rectangle is 30 meters and the length is 3 meters greater than the width. Find the dimensions of the rectangle using systems of equation. So this one's perimeter, you could see area, you could see all the different things that you know from geometry, okay? But this one says the perimeter of a rectangle. So how do I find the perimeter of a rectangle? Add up all the sides, or twice the length plus twice the width, right? This says that it's 30 meters. The perimeter itself is 30 meters, so P is 30. The length is 3 meters greater than the width. So the width I know nothing about. The width is the width. But the length is 3 meters greater, which would be W plus 3. You could see it say it's 2 times the width. So you do 2 times the width. You could see it say 3 meters more than 2 times the width. So it's 2 times the width plus 3 meters. So there's a lot of different things you could see there, okay? But they will always give you enough information to at least set up 2 equations. So the first one is that the perimeter, which is 30, equals twice the length plus twice the width. And the second one is that the length equals the width plus 3. So there's 2 equations there, okay? A systems of equation. So now, I already have it set up for substitution because it's solved for L. I'm going to take this and I'm going to plug it into the L. I get 30 equals 2 times width plus 3 plus 2W. 30 equals 2W plus 6 plus 2W. 30 equals 4W plus 6. Width is 6. And then I take that, plug it back in, and length is 9. And it said meters this time, so the unit would be meters. 6 meters by 9 meters, or width is 6 and length is 9. Usually there are some, you'll see when we get to the next section, there's some exception to this, but usually on word problems you won't put them in coordinate point. You will list them out what they are. So the dimensions here would be 6 by 9 or 6 meters by 9 meters. Questions? Okay. So I want to reiterate it so that there's no one that loses credit on their homework because they didn't listen. When you are doing your homework, the only time you're using your graphing calculator is either to verify the ones that they say to verify, or if it says graph it and then find it. Most of the time, you are not using it to graph, which means you better graph by hand. Your quiz, you will graph by hand. Your test, you will graph by hand. So you need to make sure you're showing the graphs on this homework.